Hello students, welcome back. Our today's topic is integrated circuit, which is an 8-bit DAC. DAC means digital to analog converter. So this digital to analog converter comes in a packed integrated circuit, means packed IC, one IC. And this particular DAC is of 8-bit. Okay, 8-bit means it can accept 8-bit of information, means 8-bit of digital bits it takes as input and is capable of producing an corresponding analog output. Alright, so this is the circuit which is drawn here, IC 1408. IC 1408. This particular IC is capable of doing digital to analog conversion. This portion what you see here, D1, D2, D3, D4 up till D8, these are the digital inputs from pin number 5 to pin number 12. So this is your input side for your DAC. Okay. Now this particular IC works with plus VCC 5 volt and minus VE minus 5 volt. Alright. Now another important thing here is a reference voltage of plus 2 volt is applied. V reference plus 2 volts. The meaning of this is the digital inputs, this digital input, we consider this digital input either high or low, isn't it? High or low. The digital input can either be high or low, means 1 or 0, right? For it to be considered as high, means for it to be considered as 1, a minimum voltage required is 2 volt. Minimum 2 volt minimum voltage is required. Alright, for it to be considered as high. Now for it to be considered as low, input, means that is to be considered as 0, maximum voltage is 0.8 volts. Understood? So this is for considering low, means 0.8 volts maximum it should be, then it is considered as low. And minimum it should have a 2 volts amplitude for it to be considered as high. Alright? Yeah. Because our reference is here plus 2 volts. Next. This is a very important topic from your exam point of view. Alright? In many question papers he has asked you this. So the full scale output current I0 is given as I reference. Which is this I reference? I reference is this current, okay, coming out from a voltage source of V reference. Alright. I reference equal into 1 minus 1 over 2 raised to 8. 8 because of 8 bit. 8 because of 8 bit. The full scale output voltage is given as IRF into RF, this feedback resistance. RF into IRF. IRF is here. Then I reference will be 2 milliamps. How is this? When you apply 2 volt, 1 kilo ohm resistance, the current flowing is I reference. It will be 2 milliamps with 5 kilo ohm of resistance, as RF will give you, if you substitute this 2 milliamps and 5 kilo ohm here, it will give you VFS equal to 9.961 volts. Final output voltage, we are interested in final output voltage. It is given as IRF into RF. I reference into, sorry, I was telling IRF. I reference current into RF. D1 by 2 raised to 1, D plus D2 by 2 raised to 2. So as bit goes on increasing, this goes on increasing. So up till n bit, dn over 2 raised to n is given. So since we have 8 bit here, it will end for d8 by 2 raised to 8. Alright. So this is your final output equation, which is giving you analog output value. So this is how digital to analog conversion happen. Digital to analog IC works. Okay. Actual conversion, how it happens digital to analog, for that I'll be preparing another video. Okay. For this particular topic, this much is sufficient. All right.